everybody. In this video, what I'm going to do is I'm going to give you some preparation for quiz 8 by giving you some practice problems for quiz 8. So I'm going to go with the rules that we went over in the last video. I'm going to do some problems wherein we employ those rules. And in the next video, I'll actually do some preparatory work for quiz 8 to give you some strategies and tactics for how to actually complete those problems. But for now, let's practice.
All right, what we're going to do here now is we're going to talk about strategies for your 8th quiz. So these are quiz 8 strategies. So up to this point, we've been slowly building a list that way back, remember on quiz 2, it was just arrow out. And then for quiz 3, we added and out, and in, and arrow in, and then we kept building that up and kept building that up. And that lasted all the way to quiz 7. But then in the last video, what I did was went over all the new advanced rules that we've got as well. So what I want to do here is basically say my advice for how to proceed from here. So it used to be always see if you can do arrow out first. See if you can do arrow out first. Remember, and there was the rest of that basic list. We kept adding things to it. All right, so that our recommended order changed by the end. Pretty much it always started with arrow out and ended with indirect proof with a bunch of other stuff in the middle. What are we going to do now? Well, from here, here's the new strategy for quiz 8. All right, herein I'm going to give you this recommended order of what to do when you're approaching quiz 8 problems. But there's something you should do before you do any of this other stuff, which is distributivity, look at simple conversions that you can do, the advanced rules and the basic rules. One, look at your goal. Okay, if it's an arrow in, okay, so like one of these things, go ahead and provisionally assume this and get this. Like, go ahead and work on that. It's going to come into play. If that's the recommended rule, go ahead and do it. If, on the other hand, it's an indirect proof, and I say something like, okay, you're going to get Q, well then go ahead and provisionally assume squiggle Q. Go ahead and do that with these. Okay, do it at the outset, because here I'm going to tell you what the recommended rule is at the end and how to get each problem on quiz 8. So it's not going to be a mystery in terms of what to do, like how well should I do this here? You will know what the last move is. So one of the things that you should do here is start with that and figure out backwards. Like if it says, hey, you're going to do it with an indirect proof and you're going to get Q, well then go ahead and provisionally assume squiggle Q. That's what you should do. So start with that before you get onto the rest of this stuff. Now I want to go ahead and get into the rest of the stuff that you should do after that. First thing you should do. One of your rules is the law of distributivity, or LD. Okay, so distribution. First of all, see if you can do that one. Okay, because if you can do that one, that's going to save you a ton of work. Super important, you should go ahead and try this one first, see if it's available to use. So what do I mean by that? Distribution has basically 3 possible scenarios where it could come into play. I suppose 6 depending on how you want to look at it in either direction. So if you have something like this, probably want to convert it into this. Okay, and vice versa. You got something like this, go ahead and turn it into this. That's probably going to come in handy. It also works, same thing, except with instead of the wedge, we get an XOR. XOR in place of here. The XOR, if the XOR is the main operator, this does not work. Okay, so this works. And then the third version that works is where you do have a disjunction as a main operator, but it can only be an inclusive disjunction. It will not work with an XOR as the main operator here. Okay, and that's where we've got B and C, and we can convert that into a wedge B and a wedge C. Again, there's not a version of this that works with an XOR as the main operator. So here you go. Here's 6 possible scenarios. If you see one of these 3, turn it into its respective counterpart. If you see one of these 3, you're probably going to want to turn it into its respective counterpart. And I'm going to do a couple of examples here where we'll see why we want to do that. So that's the first thing. Go ahead and do distribution if you can. So that's the first rule of advice. Second rule of advice, so the second thing you should try out. Any conversions. Now, by conversions, I'm talking about rules of substitution, but there are lots of rules of substitution. I'm particularly thinking of ones that are easy conversions. And so by that I mean like double negation, I suppose, is kind of one. I don't think that's one that we need to think about as much. I think that one's pretty obvious. But I guess we could include it in here. So I'll go ahead and include double negation here. Remember, the way that one looks is you can turn this into this and vice versa. That's a conversion. And I'll put it in here because anytime you get rid of double squiggles and just go ahead and put a vanilla version of something, worth doing. Or you can eliminate a bunch. So I'll put that here. That one I think is pretty obvious to think about, but the ones that I really have in mind are these four in these particular ways. De Morgan's law, material implication, conjunctive conditionality, and material equivalence. Okay, so these three go back to quiz 6, and they were used on quiz 7. This is the one that's new, but this is still nevertheless the next thing that I would say to do. See if you can do one of those. De Morgan's law, what does that look like? Well, that's where you can switch, remember, between, say, an and a wedge, and it looks like this. You just change all the negation slots. So remember, in simplified form, I could just say, if you're going from a dot to a wedge, or vice versa, obviously change the symbols, and then change these slots, the outside, the left, and right, as we did here in this example. This is just an example of one. This is not the only way De Morgan's law can be used. Just if you're going to flip between these two, flip between them, change the symbol, keep the letters the same, and then change the outside, left, and right negation slots as has been done here. Material implication, that's where you can go from, say, a wedge to an arrow and vice versa. And the way that works is you just flip the left negation slot. Okay, so if I'm going between a wedge and an arrow, or vice versa, you just change the left slot. Conjunctive conditionality, if I'm going between an and an arrow, I change 2 slots. The outside, the left stays the same, change my symbol, and I change the right slot. Okay, and so the way I can express that is if you're going from a dot to an arrow, or vice versa, you change the outside and the right. Okay, and the fourth scenario, and this one's new, is how to change between material equivalence. Now, material equivalence has a lot of different things that you can get out of it, but I think the one that's the most helpful is this one. You can change, for example, an XOR into a double narrow. Okay, so you can go, basically I'll put it this way, you can go between an XOR and a double arrow by just changing the outside slot. Okay, in fact, I'll go ahead and put the 2 versions here. I haven't done that for the others. I could do here. I just want to say this. Here are the 2 versions of this. I could start with a double arrow, because we have special names for this for whatever reason in logic. We call, when there's a double arrow with a knot on the outside, we call it a double narrow. We also call an and, when there's a knot on the outside, a NAND. Okay, we can call an XOR with a squiggle on the outside an XNOR. But here's the main thing that I want you to know, and this is true for both of these that I have packaged together. Here's the deal. You can switch between an XNOR and a double narrow, and you can switch between a double arrow and an XNOR. So what does that mean? Basically, you can flip between this symbol, here's where I'm going to put it, the XOR and the double arrow by just flipping the outside slot. That's it. So after you want to see, can I do distribution? Can I do any of these conversions? When would these conversions be helpful? I'm just going to go ahead and say my recommendation is to use one of these conversions when you can get rid of a squiggle on the outside. So for example, with this one, say I had something like this. Oh, look. Okay, this. I don't want to work with this. I don't like working with squiggles on the outside. Those are very difficult to work with because, for example, if you have an and with a squiggle on the outside, you can't just take this apart. You can't do an and out on this. So squiggles on the outside make things very different. You can't just do a modus ponens or a modus tollens with this. Squiggles on the outside make things very difficult. So what I would do here instead is there a conversion that gets rid of this? So if I had an arrow, what could I do that would get rid of the squiggle on the outside? Well, I could do material implication, but that would just get rid of the left squiggle. What I could do instead is conjunctive conditionality. Look, the rule here says this. You got an arrow and you want to go to an and. Uh, keep the letters, change the symbol, and only flip the outside and right negation slots. So outside is on, I'm going to turn it off. We don't do anything with the left. Outside is on, I'm going to turn it off. So look, now this is much easier to work with. Look, this ridiculous thing here, squiggle, squiggle A, arrow, squiggle B, I can convert it into this, and now I can just do a simple and out on this. This is much easier to work with than this. So that's what I mean when I say go ahead and do conversions. Similarly, this material equivalence, where this comes in handy, let's take a look at this nonsense. If I had squiggle A, X, or B, that's not easy to work with either, but if I turned it into, I could turn this, a X nor is the same thing as a double arrow, and look, now I could, if I needed to, I could, do a double arrow out. This stuff's much easier to work with than this, typically. I could think of a few exceptions, like if I could do a disjunctive syllogism, but on the whole, I'm just going to say, if you see something where you see one of these with a squiggle on the outside, look and see, can I do a conversion? So that would be the second recommended step in these Quiz 8 strategies. And next step that I'm going to say is go ahead and go down the list of other advanced rules. So what I recommend on doing at this point is just go down that PDF of advanced rules, and I think the one especially the one that's going to get the most mileage, I think, is going to be disjunctive syllogism. That would be this one. So disjunctive syllogism, that's the one that you're going to get the most mileage out of. I think you're going to end up seeing that you're going to use it the most often. You can go without it. It's just going to save you a couple of steps. So again, what that looks like, we have 3 possible scenarios. You're starting with a inclusive disjunction, and then there's 2 scenarios with XORs. So with an inclusive disjunction, if you have not one of them, you can say, yep, you got the other one. With exclusive disjunctions, you can also do that. You got not one of them, then you got the other one. But also with exclusive disjunctions, you can say, oh, I've got one of them. Well, then you don't have the other one. Can't do that with inclusive disjunctions. Now, let me also go ahead and point out here the way this looks. What if the stuff that I have to start with is negative? So what if I have something like this? Squiggle A, XOR, squiggle B, and then I have vanilla A. Well, this one here is actually this one here. You have the negation of one of them. Okay, look, so I know these are the ones that have the squiggles, but A is the negation of squiggle A. So if I find myself in this situation, what do I have? Like, you got squiggle A or squiggle B. Well, it turns out you don't not have squiggle A. What do you have then? In this, you have squiggle B is a thing. And what is that? Disjunctive syllogism. It's this one. Just this, all the squiggles are flipped. It works. Okay, so this one you'll get the most mileage of, and out of this one you can easily convert this into an arrow. So you'll notice we know it works. This one with the inclusive, what we could do, look, we could do, if we had A wedge B and we had squiggle A as our assumptions, yeah, we could turn this into an arrow. We just did a conversion where I can go from, remember, wedge to arrow by just flipping the left negation slot, so I could do that. Squiggle A, okay, arrow B, material implication on line 1. Oh, now I can do an arrow out, okay, between lines 3 and 2, and I get just B. Arrow out, 3 and 2, aha. So that means in this situation, this one only saved me a single step. Like, let's hit 1, 2, 3. This only saved me 1 step. But in these scenarios with the XOR, there is no, you can't turn an XOR, you can't do De Morgan's law with an XOR. Okay, we could turn it into a double narrow. That's not going to get you far, though, unfortunately. So if we tried to do that, I think you'll find that the situation becomes pretty difficult if we did that. So let's say we had A XOR B, squiggle A, solve, try and get B. Try and get B without it. And you'll see here that now all of a sudden, since there's no De Morgan's law or material implication that we can do with XORs, this becomes much more difficult to do. It's possible. But we can convert this into a double narrow, sprinkle A, double arrow B. Now we've done it, all right, so this would be material equivalence on line 1, but here, this is not helpful. This is going to be a really long proof, actually, to do without it. So this one's pretty simple. It just saved us 1 step. Here, this saves us at least 10 steps in both situations. So that's why no to do disjunctive syllogism. It is one of the most useful. Also, conjunctive syllogism is really useful too. I think you'll find this one you'll be using the most. And then the other ones. So really what I recommend doing after seeing if I can do distribution and then seeing can I do any of the conversions, and then go ahead. I think the first one I would check and see if I could do, can I do a disjunctive syllogism. Then just go down the list like this. All right, do I have the stuff that meets the criteria for this one? This one? This one? Like, see, does this stuff match here? There's little explanations under each one. This one, distribution, that should be the first thing you try. What about this one? This one? Yeah, really, just go down this list and keep looking to see, like, does this one apply here? Does this one apply here? Does this one apply here? There's disjunctive syllogism. Does this one apply? So try all these out just to see. Again, here's the material implication. I said, you can go from double arrow to XNOR, and you can go from double narrow to XOR, and there's other ones on here that are kind of spicy too. I'll go ahead and say these are going to be rarer. The one that you're going to use on quiz 8 definitely is material equivalence that gets you from this to this, and also from this to this. That's going to happen. The others are going to be much more rare, and these are usually not necessary, but they are things that you can do. Okay, and then dispersion. Here's another one. It looks a lot like distribution, except there's arrows involved and how these arrows carry over. So I guess we could say this is actually dispersion is making the A get cast out into this, and this, I suppose, going from this to this is agglomeration. We'll call the whole thing dispersion. This is on quiz 8, but it's not very common. So I'll say it is there, but it's not there a lot. Okay. So what do I do after I've gone down the list of these 20? What do I do next? Well, at that point, my recommendation, and again, disjunctive syllogism is just probably going to be the one that you're going to use the most often. Probably after that, hypothetical syllogism and conjunctive this bunch. You'll use the others too, but I think these are the ones that are going to be the most common ones, the most commonly used. After that, then use your basic rules. And that's going to be the same list that you had for quiz 7. Okay, so nothing will have changed from that list. So what's that going to look like at this point? Well, so that would mean going to once you get to this part, you'd go through the list: arrow out, modus tollens, double arrow out, double arrow in, hand out, hand in, double negation. I'm going to say wedge in, wedge out. The one thing I'm going to leave out here at this point is the De Morgan's law, material implication, and conjunctive conditionality, because that should have happened here. So those should already been looked at. I guess double negation really would go into there too. But we'll say, so I could say that one's kind of already been done. But I guess you could do another check and see what I want to use it again here. But yeah, those 3 that were here, I'll just put them that they were here. These 3, they really should have already been used at this point, but maybe you could do a double check again. Can I do one of them now? And then your last case scenarios are actually going to be arrow in and indirect proof. Okay? So, only at this point would you then employ these. Now, all semester long, these have been the go-tos. And they're still going to be used. Actually, I think most, if not all of these, are going to be employed on quiz 8, if memory serves. But they shouldn't be your go-tos at this point. You want to start with this one, check these out, and then go to the rest of the list first, just to save you time. Every problem on quiz 8 is actually doable with just these. It is doable. Some of them will take an outrageous amount of steps, but every problem on that quiz is doable with only these. And so you can do it that way, and it's completely fine. However, quiz 8 incentivizes you to use these because bonus points are offered for doing it in X amount of steps. So, if, for example, if you can do a problem and it says, hey, you can actually get this problem done by step 11 with this move. You don't have to do it that way. You get full credit for doing it a longer way with only these. You'll get extra credit for doing it by X amount of steps with a recommended last move of what I provide for you. Okay? So what I'm going to do next here is I'm going to do some practice problems with this strategy in view. We're going to do the can I do a distribution, conversions, advanced rules, basic rules. And then what I'm going to do is I'm going to give you some setup for the Quiz 8 problems themselves. So I can give you the advice for this semester's, but that's going to change every semester. So that's why that's going to be in a separate video. That's going to change every 6 months or so. So for now, for this video, let's do some practice problems which are not on the quiz, but are nevertheless indicative of the strategies that you will employ on Quiz 8. All right, let's look at our first preparatory problem. We've got these two assumptions, these arrows, and our goal is this. Now, I'm also going to give you a preview of what Quiz 8 is going to look like in this regard, too. So let's say I said, solving this problem gets you 10 points. But if you do it this way, you'll get an additional 5 points if you're able to get it done by line 8 or fewer, and with a recommended last move of an arrow in. Okay. Now, so here's the deal. This takes you 20 steps, 10 steps. You get all 10 points. If it takes you, if you can get it done in 8 steps or fewer, you'll get an additional 5 points. Now, this is not an actual Quiz 8 problem, but it's indicative of the kinds of problems you'll have on Quiz 8. And here's the way it's going to work. Try and get it done by this many steps or fewer. And my recommendation is that you finish it with an arrow in. It's possible to finish it without it, but that's my recommendation. So the recommended order is this. See if you can do a distribution. Nope. See if you can do conversions, especially if there's negations on the outside. There's no squiggles here, so I'm not worried about that. See if you can do advanced rules. There's some that we can do, like we can do dispersion on line 1 and dispersion on line 2. And you can solve the problem that way, but it actually is going to take you longer than 8 steps. So I wouldn't recommend it. Well, then why did you say to do this, Professor Burris? Then do basic rules. Well, here's why. Here's another aspect tactically that I want you to think about that is imperative for Quiz 8. Look at what you're solving for and look at what the recommended move is. So if you know the recommended move is going to be an arrow in, then you know you're going to provisionally assume this and try and get this. So you can actually start with that. Yeah, there's other things that we can do here, but this is another element that I'd put in here. Look at what your goal is first. So once you do this, then do those recommended moves. So this is an important part of the strategy as well. Yeah, sure, do this stuff, but do this first. Look and see what my goal is and start backwards from there. So here I know I'm going to PA this, and I know I'm going to try and solve for this. So I'm actually going to go ahead and plug that in. So I'm going to go ahead and say the left side is S wedge P as my provisional assumption, and I'm going to shoot for Q. All right, so now I've got that in play. Go down the list. Distribution, no. There's no conversions that I think are worth doing. Again, we could do dispersion, but there's actually something else to do right now. Look, we're staring us in the face. This is an or out waiting to happen. Look, we have a disjunction. And look, just like a Quiz 7 scenario, we have an or statement, and look, one disjunct is on the left side of the arrow. The other disjunct is on the left side of another arrow. So what that means is we can put the results together as a disjunction. So that's going to look like this. Q dot T wedge Q dot R. That's wedge out 3, 2, 1. Again, you can put the numbers however you want in any order as long as it's the right number. So we got this now. Now this is a shape, a wedge of 2 ands. Go back to the top of the list. Can I do a distribution here? Yes, I can. Actually, it's the rule distribution. I'm actually factoring the Q out. If I have Q and T or Q and R, using the law of distributivity, and again, technically it's factoring here, or factoring the Q out, but we get this. Or we can get Q and T wedge R. Fantastic. What do we do there? Law of distributivity on line 4. Now here's why that's really, really helpful. Look, now we can AND this out. We get Q. Now wait a minute. That's what we were trying to get. Really, that's it. The arrow in is done. So check this out. We can say AND out on line 5. Now if you're wondering, what do I do with the T wedge R? You can go ahead and get it out. That's not at 7. So you can go and get it here. And I'm just going to put it in brackets. You don't have to do that at all. I'm just going to say here, this is a superfluous derivation. We're not going to do anything with this. We don't need it. But if you're like wondering, what do I do with this? Where do I put it? You can put it there. But then look, here, I got it. I can zoom out and say, yeah, you got S wedge P. You can get Q. We could actually be done by line 7 if we didn't include this because we don't need it. That's not going to get you any more bonus points. So that's why in any instance where there are superfluous derivations, I've included them in the calculation. So you don't need to worry, what if I don't know that I don't need it? You don't need to worry about that. So that's why I put this as 8 steps instead of 7. But then we can just go, look, arrow in, 3 through 6. You put 3 through 7, that'd be fine. Because you got that out from this too. And look, problem's done. And what was new here is we used this rule. This hasn't come up before. And if we didn't use this, this problem would have been at least 12 steps longer. Because to go from here, this line 4, to go from here, this probably would have taken about 20 steps without the law of distributivity. So that's why I'm saying check this one first. Let's try another practice problem. All right, let's do this one. We got squiggle Q wedge P. We want to get squiggle P wedge S. We're trying to get squiggle Q. It can be done in 7 steps. Indirect proof, recommended last move. So let's go ahead and start with that. We know then this is going to happen at some point, so let's go ahead and get out of the way. This is a provisional assumption for really any contradiction. All right, go down the list now. Distribution of thing? No. Conversions? There is a squiggle here on the outside. But if I were to convert this into squiggle P and squiggle S, and then I De Morgan's law things out, the only thing I would end up getting is I would get Q again. Like I could get squiggle P out and then do a disjunctive syllogism on line 1, and it would just get me regular vanilla Q again. So that doesn't seem like it's worth doing, so I'm not going to do it. Advanced rules, disjunctive syllogism staring us right in the face. Look. You got an OR statement. You got, oh, not this one. So definitely this one. Disjunctive syllogism. 1 and 3. Okay. So now we got P here. Then what we can do is watch this. We have this. Since we have P here, we can actually build an opposite right there. Look. So that's one of the things you want to look for when you're doing an indirect proof. Can I build an opposite? And that's why in an indirect proof, having squiggles on the outside is actually helpful. So watch this. I can just go P wedge S. Wedge in on line 4, and then look, line 5 and line 2 are contraries. So I can say P wedge S, and the exact same thing with a squiggle in front of it, and in 5 and 2, and quest complete. I can zoom out and say, yep, squiggle Q, indirect proof, 3 through 6, and I got the criteria for bonus points. All right, let's take a look at this one. And it says we've got J wedge squiggle F. We've got squiggle J arrow F. We're going to solve for J, and it can be done in 4 steps with a recommended final move of impossible antecedent, okay, which is one of those advanced rules. So first of all, let's take a look at it. Distribution of thing? No. Conversions? I'm going to say this, generally speaking, arrows are the best thing to work with. It might not seem obvious to you here, but watch what happens. I'll just say when we turn line 1 into an arrow, especially when we got the same letters. Look, we get squiggle J, arrow, squiggle F. All right, now that's material implication on line 1. So this is why we just want to explore some things, see what we can get out of it. Now there's actually something we can do right now and be done. Like, we can be done right now. So what do you want to look for? Well, distribution is not a thing. We already did a conversion. Go down the list. Okay, and if you go down the list, I know the recommended rule is going to be, this is where use the parameters to your advantage. I know the impossible antecedent can be done by line 4. Well, the next line is line 4. So probably I can go ahead and stick this here. And what you do, go to the advanced rules. How does impossible antecedent work? Well, you get 2 arrows. Do we have 2 arrows? Yes. And you have the same thing on the left side, but you have contraries on the right side. What does that mean? The antecedent that matches makes no sense because it's literally going to lead to an indirect proof where f is true and its opposite is true. No, so that can't be a thing, so squiggle j can't be a thing, so j is a thing. Impossible antecedent, 2 and 3. And actually, we're done. That's it. Now, if we didn't do it, we could provisionally assume the opposite of j, which would be squiggle j. We'd get out f and squiggle f. We'd put them together in an indirect proof. I think it would take about 7 steps. Or we could just be done in step 4 with impossible antecedent. It lets us get that. It lets us see that the indirect proof is kind of already staring us in the face and that this is nonsense. So that's what this allows us to do here. But knowing that we can do this advanced rule is what makes this a quicker process and would get us the bonus points here. Let's look at another one. Okay, let's take a look at this one. Got P arrow Q, Q arrow squiggle R wedge P, squiggle S arrow Q, S arrow M arrow L, R by itself, and M wedge P. And we're going after just L by itself. Now see, it can be done by step 14. Whoa, that's bigger. And last move is an arrow out. This gives us a hint because, look, remember the shape of arrow out works like this. And I'm going to put it this way here. We know that the result of an arrow out is the right side of an arrow. So we know at some point we're going to have some left side and some left side going into L. Like some left side arrow L, left side match of some kind, and that's going to get us L. That's going to happen at some point. So really what's going on here is algebraic. We're having to figure out what's the mystery left side here. That's what's going to play out here in this problem. So let's go about and see what we can do. See things that we can build. So distribution, not necessary here. Not even possible either. So let's see what we can start building. So conversions, there's no squiggles on the outside, so that doesn't seem necessary here. Advanced rules. There's some things I can do right now, but I don't know if they're going to be helpful yet. I will say this, and you might not see it at this point. It is going to be useful in this problem. Line 4, there is a rule that we can do on line 4. If you go take a look at exportation, exportation allows you to take, if you have nothing but arrows and a heavy right, then you can take the tiny left and the left side of the heavy right and put them together as a conjunction. In other words, here's how it looks. If you have A arrow, B arrow C, you can convert that into A and B, arrow C, and vice versa. So that's something we could do on line 4. And we'd want to. Why? Because take a look at it. If we did that on line 4, that would get us the following. We would get, if we did this rule exportation on line 4, we would get S and M arrow L. Now look, now an L is on the left side of the arrow. So all we had to do, if we could get just S dot M, we could get a left side match for this, and we'll get the L out. That's exactly what we need to solve the whole problem. Line 14, we're done. So really now all we need to do is get S dot M. That's exportation on line 4. Now you might not realize that you can do it just yet, but I'd recommend go for it. This is where doing those advanced rules, we could do that here. Now all we get, if we can get S dot M, and I see them, there's some S's in here, there's an M in here floating around. If we could get to these and put them together, get them by themselves, we could just unlock the L. The whole problem's done. So let's try that. So for example, next thing I want to do, advanced rules seem to be exhausted. I just did one. Basic rules, I can do a wedge in that's helpful. Watch this. Now look at my arrows. I've got. You want to look at arrow outs. Do I have a left side match? Q, P, Q? No. right side contraries or opposites. Do I have a squiggle Q? No. Do I have a vanilla R wedge P? No. But I have R, and if I could just wedge in a P, then I could get the contrary to this. That's what I'm going to do. R, wedge P, bam. So this is a quiz 7 move here. Wedge in onto line 5, and look, now I have a right side contrary for line 2, which means in line 9 I can get squiggle Q. Modus tollens to an 8. Now, with this squiggle Q, there's actually a couple things I can do. I can do 2 modus tollenses right now. I can do one here, and when one of these basic rules is obvious to do, probably a good idea. You can at least try it out. So 2 modus tollenses, line 1, line 3 with this new squiggle Q here. I'm going to get the top one first. I get squiggle P, modus tollens 1 and 9, and I get squiggle. Actually, I just get plain old S because I already have a squiggle S as the left side of line 3. I get S modus tollens 3 and 9. Now look, if I go distribution, no. Okay, and I know my last move in line 14 is going to be L, so I'm even just going to go ahead and stick that there. I know L is going to happen here. I know it can happen here. Go through the list. Distribution, no. Conversions, none are necessary. Next one, disjunctive syllogism, conjunctive syllogism, hypothetical syllogism. So disjunctive syllogism, look, do I have any wedges? I've got this one, and I've got this one. Okay. Do I have any contraries to the disjuncts? Well, I do for line 8. I've had one, but that's just going to give me R, which I already have. But I have this one on line 6. Look, I've got M wedge P, and I've got not P. So what do I know? M. That's disjunctive syllogism 6 and 10. That's going to be really helpful because now remember what I was trying to build. I was trying to get the left side of this arrow, and now I know it's S dot M. And I kind of figured that out with the exportation here earlier. And so look, now I needed this, and now I've got here S dot M. At least I've got them separately right here. So now watch this. I can just stick them together. S dot M. Okay, that's and in. That's and in 11 and 12. And if I didn't make that exportation earlier, I could make it now. And look, there's my left side match for that arrow. Arrow out, 713. Problem's done. Okay, we could have done it. We could have done it only using the basic rules, but it would have taken a lot longer. Here it gets done in line 14. All right, let's take a look at this one. We got F arrow O, F arrow W, F arrow O dot W. It says we can be done by line 4 with dispersion. Well, there's another way. There are other ways to do it. In fact, I'm just going to show you that it can be done otherwise. But then I want to show you why it would be wise to use dispersion. So if I were going to not use dispersion, I could do this. And this is going to seem a little bit backwards to do just to show you. I could do material implication on line 1 and get this. Material implication on line 2 and get this. I could stick them together. Squiggle F, wedge O, and squiggle F, wedge W, and I could say, oh, that's an and in, 3 and 4. And then I could do distribution on line 5 and actually factor the squiggle F out and get squiggle F, wedge, O, and W. Okay, and that would be a law of distributivity on line 5. And then I could convert this with the material implication into F, arrow, O, and W. Oh, look, problem is done. Material implication, line 6. Problem's done. But it said I could be done in line 4. Here I am done in line 7. And this took a lot of backwards thinking to get here. I just want to show you how much easier this is to do if you just follow the directions and the recommendations. So it says the last move is dispersion. How does dispersion work? Well, it's the last rule in that advanced set of rules, and it says this. If you have A arrow B, and you have A arrow C, then that is the same thing as saying you've got A arrow, B, and C. So what you want to look for, do you have two arrows where the left side is identical? And then do you have two separate right sides? Then you can put them together as an arrow where you have one solid left side and then those other two as an and. Well, look here. We have two matching left sides. Now we could also do this with a arrow in as well. We could provisionally assume the left, we get O out, we get W out. We could put O and W together. And that there too, if I were to do the math on it, that would be 3, 4, 5, 6. That would be done on line 6. That would be actually a little bit quicker. But we can be done by line 4. How? Well, we can build this. Line 3. F arrow O and F arrow W and in. And then look, now we can do dispersion. Line 4, we can say F arrow O and W. Dispersion, line 3. And the problem is done, and you would have gotten the bonus points for it in this case, plus 5 bonus points, because of the way quiz 8 is going to work. That's why knowing how to do the rules, looking at the recommendation here, is actually going to not just save you time, but also give you additional points. All right, let's take a look at this problem. We've got squiggle x dot z, p dot r arrow x, squiggle p dot r, x or m, and we've also got squiggle m. We're trying to get squiggle z. It can be done in 8 moves. Last move is conjunctive syllogism, which means we know we're going to have a dot with a squiggle on the outside, and we're going to end up getting squiggle z. So I think that whole x dot z is a good candidate here, which means at some point during the problem we're going to get x. So really the goal here is to get x by itself. We get x with what we've got here in line 1, we can get squiggle z. And the goal, like I said, is to be done by line 8. So really we should be able to say squiggle z, conjunctive syllogism, and then whatever the numbers are here. So that's what we're going to shoot for. Let's see then what we can do now. So in terms of stuff to do, law of distribution doesn't look really applicable here. Conversions. Any conversions I can do where I get rid of a squiggle on the outside? Yeah, line 3. Look, this is an X NOR, so I can turn this into a double arrow. And it ends up getting me squiggle P dot R, double arrow M. That's material equivalence on line 3. And then look at this. What can I do now? Okay, distribution, no. Conversions, no. Advanced rules. The first advanced rule I can see is the second one actually on that advanced table, which is biconditional tolins. This gets me here, P dot R. Biconditional tolins, that's 5 and 4. Because look, I have a double arrow, and I have the opposite or the contrary of one of the sides, which means I can get the contrary of the other side. So I have here's M on one side of the double arrow. I have squiggle M, which means I can get the contrary of this. The contrary of squiggle P dot R is P dot R. Now you might be tempted to break it apart, but look, it's already itself a left side match. What does that get me? X, arrow out, 2 and 6, and then look at this. I'm saying this. You can't have both X and Z. Well, we've got X, so we can't have Z. So what is this? Conjunctive syllogism, line 1 and line 7. And thus we're done in line 8. We did it via conjunctive syllogism, and the proof is done. All right, let's take a look at this one. We got P wedge R, squiggle P wedge Q dot R, and we've got R arrow Q dot S. And we want to get Q dot S. So here's what I'm going to say here. This problem is doable, insofar as I'm aware, in 6 lines or less, with a final move of arrow out. That means you can be done. 3 more moves and you're done. In fact, I've seen this problem done in a much more lengthy way. So I'm going to go about it the lengthy way first, just to show you it can be done that way. That involves some advanced rules. And then I want to show you how, if you can just see what you're looking for here and do the advanced rules, you could be done by step 6. So let me do it kind of the long way. And this is the way that the first time I ever did this problem, I did it the long way. So here's what I would do. So first of all, let's commute line 1. We get R arrow P. Okay? That's law of commutation on line 1. Now, then what would I do? I would, after I commute it, I would turn that into an arrow. Scribble R arrow P. Okay, material implication on line 4. Why would I do that? Alright, I would do that because then I could also turn line 2 into an arrow in line 6, P arrow, Q dot R. Material implication in line, this would actually be line 2. Let's tidy that up a bit. Material implication on line 2, and then I could say, hey, hypothetical syllogism, squiggle R, because of this P being the middleman, leads to Q dot R. Okay? Hypothetical syllogism, 5 and 6. And then I could turn this into a wedge through material implication, R wedge, Q dot R. Material implication on line 7. Then what I could do is I could use distribution on this. I could distribute out the R and get the following. R wedge Q and R wedge R, the latter of which is silly, but that would be the law of distribution on line 8. Then I could break these apart. R wedge Q, R wedge R, and out on line 9 for both. And then this is an example of idempotence. I could just say, hey, that's R. Id on line 11, just, saying it's a table or it's a table is the same thing as saying it's a table. And then now, look, I can do a classic arrow out between lines 3 and 12 and get Q dot S. Arrow out 3 and 12. Okay, this works. This gets you full 10-point credit. This is not a Quiz 8 problem, but it could be. But look what the parameters say. The parameters say you can be done in line 6 with a final move of an arrow out. Now, our final move was an arrow out, but we could have been done in half the time if we had studied this carefully. So that's what I want to do next. I want to see how could we solve this problem and be done by step 6. And that's really the goal of having all these advanced rules, is to figure out how could we do this much more quickly and easily. And it's really a matter of seeing, is there something that you could do that could make this easier? Which is not only a good skill for Quiz 8 and for this class, but for life. Is there work smarter, not harder? And this quiz incentivizes that. You get more points for working smarter and not harder. You're not going to get more points for doing more work, so to speak, for writing more down. But you are going to get more points for saying, oh, this does apply here. So let's see what we can do with this exact same problem that gets it done in less than half the time. Let's do it. All right, same problem. You can be done by step 6, which means, look here, that means this. 4, 5, 6. We can be done. We're going to have Q dot S by here. And it's going to be an arrow out. I'm going to go ahead and stick this over here. We can be done with an arrow out by line 6. How is this possible? Well, what I want you to do in order to figure this out is scan the rules. Look at the advanced rules. What rules are available to me that would do something here, that would get the work done? So look at what I've got and then look at the rules. So you want to look down the rules. You want to start with biconditional ponens, biconditional tolons, see what's available. And as you continue to go down the list, you'll find 18 examples or 18 different kinds of rules deep. You'll find this rule called resolution, which says this. If you have a wedge statement, and then you have another wedge where you have a disjunct in one is the contrary of the disjunct in the other, you can put the two together as themselves a disjunct, or disjunction, I should say. So look, if I had A wedge B, I had squiggle A wedge C, I could just say, all right, well, obviously these two things cancel each other out. These things are going together as an inclusive disjunction. Is that scenario going on here? Yeah, look, I got P wedge R, and I've got squiggle P wedge Q dot R. That means these P's are canceling each other out, but this R wedge Q dot R is a thing. So look, I can say R wedge Q dot R is a thing. Resolution 1 and 2. All right, so that's good. How do I move from here? So I've got line 4. So how am I going to get from here to Q dot S? This means now look, if I know my last move is going to be an arrow out, this means somehow here, I am going to get an R by itself, such that I'm going to be able to do an arrow out between 3 and 5. I know that's what's going to happen. How can I go from this to just an R? Is there possibly a way? Yes, there is. Obviously, I'm going to have to go through the list of rules again. Somehow I'm going to have to get through from a situation that looks like this. Where do I have a situation where I've got a wedge, and I've got something where I've got another letter and the same thing again? That leads me to just that letter by itself. So if I go through all the rules, that is saturation. Now, if you look at the rubric of saturation, the A here is originally on the left side for this, but this is the scenario. Look at it. I've got this R wedge Q dot R is the same thing as just saying R. Now, the example I have in the advanced rules is something like this. Say I'm going to Washington, D.C., or I'm going to Alexandria, Virginia, or I'm going to Washington, D.C. Okay, it's flipped around a bit, but it still works the same. I'm going to Washington, D.C., or I'm going to Alexandria in Washington, D.C. So what am I doing? I'm going to Washington, D.C. What's the rule here? A saturation. Line 4. And then look. This here, that's the left side match to line 3. Arrow out, Q.S, 3 and 5. Problem's done. So yeah, we could have done it with many more steps. Many more steps. We could have done stuff with indirect proofs, where we assume squiggle Q.S. Get some modus tolenses. That gives us squiggle R. Squiggle R would get us, other things. All right, and we'd eventually work it out. But this way is the quickest way. You're done by line 6. Only because we know resolution and saturation and so on. So what I'm going to do in the next video is I'm actually going to give you tactics for individual problems on quiz 8. So we're going to go through quiz 8, and we're going to go through each problem. I'm going to say, not here's the answer to each one, but here's how to prepare for each one. Here's how to get a plan of attack for each one. So none of them will be something where you're simply lost to your own devices and you have to completely figure it out at random. I will give you a plan of attack, but it will be up to you to actually execute the attack. All right, so that's what I'm going to do in the next video.